Hi everybody, welcome to another of Mrs. John's videos. Now this is just wrapping up everything at the end of this topic on forces, so you should be nearly ready to do your assignment. However, I just thought I'll make this little video to bring some force concepts to light so that you get the right understanding of this topic. Now, the first thing is the force of gravity or gravity force. So anything that is falling freely through the air, if you ignore air resistance, there is only one force acting on it, and that is the force of gravity. So if you're throwing something up into the air, I've got this whiteboard marker, as long as it's in contact with your hand and you're moving it up and down, there is a push force, yes. But the moment it leaves your hand, it's no longer touching your hand. So when it's up in the air, there is no longer any push force, and the only force acting on it is the force of gravity. So if I just draw the path of a ball, that's on its way up and that's coming down. It doesn't matter whether it's going up or down. The whole time there is only a single force, and that is the force of gravity. And even when it's right at the top there, even when it's stationary but it's still up in the air, there is the force of gravity pulling it down. Gravity doesn't stop when it's at the top. Okay, the effect of this downward force of gravity, that is the unbalanced force, is to cause it to accelerate. So this unbalanced force is actually in the opposite direction to motion when it's going up. So what's going to happen is it's going to slow down or decelerate. Once it's at the top, it comes to a stop. The unbalanced force is still acting downwards, so it starts to come down with greater speed, so it's accelerating on its way down. Okay, now this is true of all objects in the absence of air resistance. However, if something is falling through the air and we take air resistance into account, let's say it's falling from a great height. These are like skydivers, parachutists diving off from light planes. Okay, so you fall to the ground. When it's falling, initially the only force acting on the thing is the force of gravity, but as the object keeps coming further and further, it starts speeding up. And then, so initially there's a force of gravity, and the size of the force of gravity is the same the whole time. So the length of the green arrow is the same. Okay, so that's falling from a height, it's coming down. However, as it starts to come down, it gains speed, and there's the air pushing against you, so there's air resistance. So the air resistance is initially very small, but it gets larger and larger, and at some stage when these two forces are equal, the forces are balanced and your acceleration becomes zero. Over here at the start, your acceleration is 10 meters per second squared, which is the same as gravity, but as it goes further down and the air resistance gets greater and greater, your value for acceleration actually decreases and it becomes zero when it's falling at constant speed, and this constant speed is called terminal velocity. Okay, so that's about terminal velocity. And this last thing that I wanted to bring to your mind is about landing on the ground. So if you are just standing on the ground, let's try and draw you. Okay, there are two forces. There's your weight force, gravity force, which acts downwards, and there's an equal and opposite reaction force from the ground, which is acting upwards. So your reaction force equals gravity force, and so your acceleration is zero. You're not going anywhere, you're just standing there. Okay, so the forces are balanced. However, if you're jumping from a height and landing on the ground, so this is jumping down, you're landing on the ground to land on the ground. What's actually happening is you're coming really fast, okay, and you're getting faster and faster, the acceleration's downwards, but the moment you land on the ground, you have to come to a halt, Okay, so then the ground has to offer this reaction force, which is really large because you're decelerating to a stop. When you decelerate, so the deceleration, your unbalanced force has to be opposite the motion. So when you're landing on the ground, what happens, this is you're jumping down, you're landing on the ground. Your gravity force is the same. However, what's going to happen is your reaction force from the ground is going to be really large. And your feeling of weight has to do with the feeling of reaction force. So you could feel lighter, you could feel heavier. When you're just standing on the ground, you feel normal because the forces are balanced. But when you're landing with a thud on the ground, you could break your bones. You feel that big reaction force acting upwards. Okay? If there is no reaction force, you're going to feel weightless. When does that happen? So that's not a part of this. Like if you went to Rainbow's End and you were on the fear fall, you know, it takes you right up and then just drops you down. When it drops you down momentarily, you kind of lose contact with your seat. There's nothing to support you upwards. So that's when you feel weightless. Okay, so when there's no reaction force supporting you upwards, you feel weightless. So I hope that made sense, this little lesson, and I hope to see you on Zoom at some time at 1 o'clock. So bye for now.